I'm just going to go through both of these ones a little bit faster, and hopefully you can see the pattern. So sp3d comes from mixing one s orbital, 3 p orbitals, and 1 d orbital. Okay? And so if we look at this for phosphorus, right, here's phosphorus, and this is why we started talking about things that can violate the octet rule. Well, hopefully you can see why they're able to do that, because they can now hybridize with the D block. So they can spill over into the D block. And phosphorus, we recognize, is 3s2, 3p3. Okay? So when I promote one of those s electrons, that gives me 1, 2, 3, 4, 5 unpaired electrons, which means I can make 5 sigma bonds. All right, and here they are. 1, 2, 3, 4, 5. And I can get 5 bonds out of that, because now if I pair this phosphorus up with fluorine, for example, and remember fluorine as an atom looks like this, right? Fluorine's 7 valence electrons. It has 1 unpaired electron. So it is quite happy to pair up with that sp3d hybridized phosphorus to give us 5 sigma bonds, which we call trigonal bipyramidal for the electron geometry. In this case, also the molecular geometry would be trigonal bipyramidal. But we recognize that if, let's say, if it weren't paired up with 5 fluorines, if let's suppose there were some lone pairs on phosphorus, it's still going to adopt, or excuse me, no, I take that back. Phosphorus, because it has the 5 unpaired, doesn't really want to create an extra electron pair. It wants to create 5 bonds. But if you look at sulfur, sulfur contains 1 extra, so that's why we can often see sulfur having electron pairs, like a lone pair on the sulfur atom, or we also see sulfur readily forming 6 bonds. And I think I have that next. Yes, the next one, SF6. So we recognize sulfur with 6 valence electrons, 1, 2, 3, 4, 5, 6, 3s2, 3p4. When all of these promote, you now have 1, 2, 3, 4, 5, 6 unpaired electrons, which we call sp3d2. So 1s, 3 p's, and 2 d's to give me 6 bonds. It will make then what we call the octahedral geometry. Okay? So I want you to be a little bit more familiar with sp, sp2, and sp3, because those make up almost everything that you'll encounter in the real world in chemistry. But certainly recognizing that the trend continues. If we want to make 5 bonds, sp3d. If we want to make 6 bonds, sp3d2. We could make 7 bonds with sp3d3, although that becomes increasingly more rare. Okay?